When we're doing bivariate relationships, we have no statistical control. What does that mean? It means that a variable that has a relationship or that varies with another variable is all we're really seeing is that in a vacuum. We're not seeing how other variables might be influencing the outcome variable as well. So let's take an example and we'll do our pricing Toyota Corollas, and let's look at the correlation matrix. If we look at the correlation matrix, what we're able to see here is we're able to see that a lot of these variables have pretty strong relationship with price. Age in years does, not surprisingly. Kilometers does. Driven, that's what's on the odometer. And then also the weight of the car does. And so these variables all have a relationship with price. So one way to think about that is that it could be that all three of these are influencing price. It could be that one's influencing price a lot and the other's influencing price a little bit, or it might be that they all have independent contributions to price and have an independent effect. And we really can't see that in a correlation matrix because what it's doing by definition is it's just looking merely at one variable in relation to another variable and ignoring all other variables. So therefore it lacks statistical control. Let's go ahead and build a model for this. I'm going to go ahead and create a derived data set where I split our original sample into some data that we'll use for training and some data that we will use for actually validating. So I'm clicking this so that we'll use 1,000 records to train the model, and we'll use 436 records to be able to see how well the model fits when we throw new data at it. I'm going to fix the random sequence here. What this does is it fixes it so that it doesn't draw a different random sample every time I do a sample. And I'll just call this partition this new model so that it's just help myself remember that it's been partitioned. And we'll select all the variables and create. Now when I look at this, this is a descendant of this original data, and it says that the 1,000 rows are for training and 436 rows are for validation. Therefore, when we actually build a model, we'll be able to see how well the model does on the training data. And then when we put new data to it, we'll see if the new data really sort of maps to the old data very well and how trustworthy the model actually is. Now we're going to use a regression model, and we'll use a linear model. And I'm going to go ahead and drop this on top of that partition data and say select the item to be predicted in its price. And it builds the model. So now this model is hooked to this partitioned data set. If I bring this up and look at the summary viewer here, what I see is that here are the relationships, the statistical relationships between each one of these input variables and price. What we see here is that all the model, all the variables all together have a very strong relationship with price. So when all of these are taken into account, the model is explaining about 85% of what happens in price. So that's a lot. It's a high proportion of the variance in price is explained by these items that are in the model itself. If we look down, we can also see that these are statistically significant. Each one of these independent variables is statistically significant, very much so. So there is definitely some independence going on here, so that age in years is contributing, kilometers, which is the odometer reading, is also contributing, and then weight of the car is also contributing to price. So all of these are. Now, because regression applies statistical control, we can actually say that if you hold weight constant, then kilometers actually has an independent effect on price, and so does age of years. Or if you hold age of years constant, then independent of age of years, kilometers is also influencing price, and so are weight. So that's the idea of statistical control, something you're getting out of a regression model that you're not getting out of pure correlations. The other thing is that you can see that the validation data set performed as well. In fact, just a teeny bit better than the training validation set. So the model is very strong. It held up very, very well, so that sometimes If the training data is a little bit different from the validation data, you'll have a little bit less in the validation, or sometimes a lot less R squared in your validation. And so this held up really, really well. So that is the concept of statistical control in relation to a model, a modeling method. You don't get it out of correlations, but you do get it out of a method like multiple regression.